so here's our circuit that we're going to work through. Our question says, consider the following circuit with a battery and an ammeter with negligible resistance. 3 resistors are connected. So here's my battery. Alright, I know my battery is 25 volts. Okay, because that's given to me on my diagram. I'm assuming that this purple was given to me in the exam or test. I have a 1 over there, so that's my ammeter 1. I have ammeter 2 and ammeter 3. I have a 4 ohm resistor there, a 3 ohm resistor and a 2 ohm resistor there. Alright, I then have voltmeter 2 connected over the 3 ohm resistor and voltmeter 1 connected over the 4 ohm resistor. So when I get a question like this, I look through it and analyze what they've given me. Okay. So now my first question says, calculate the total resistance. So now I have a series and parallel circuit. So I'm going to calculate the total resistance for my series and parallel combinations. I start by calculating the total resistance for my parallel components. So I say 1 over R parallel is equal to 1 over R1 plus 1 over R2. Alright? Then it doesn't matter which values I fill in where. There's 1 over 3 plus 1 over 2 gives me 5 over 6. So 1 over R parallel is 5 over 6. What do I do now? I invert them. Yes. So I have R parallel is equal to 6 over 5 is equal to 1,2 ohms. But that's not my final answer. That's just my total resistance for the parallel component. So now I have to add my total resistance for the series component. So now I say R series plus R parallel equal to R total. So now I add my 4 plus 1,2 gives me 5,2 ohms. There is my total resistance for the circuit. Are we happy with this? Everything I've done so far. Very good. Alright, so now question 2 says, calculate the reading on ammeter 1. Calculate the reading Alright, calculate the reading on ammeter A1. So, ammeter A1, what is it measuring?
The amps.
Amps, total current of the circuit. Right, ammeter A1 is measuring my total current of the circuit. Alright, so to calculate this, I will always start with my formula. R is equal to V over I. Alright, this is the formula I start with. Remember to always write, for my grade 10s, always start by writing your formula like this. Alright, R is equal to V over I. Don't manipulate it or use your triangle. Grade 9s, you can manipulate and use your triangle. Okay, so calculate the reading. So what resistance value am I going to use here?
5,2.
5,2 ohms, yes, because I'm using my total resistance. 5,2 ohms is equal to my voltage, which is there, 25 over my current. This is my A1 reading. So I calculate it.
4,62 amps.
Alright. I got 4,81. Alright. I is equal to 4,81 amps. Alright, so now I have my total current. That's my reading on my ammeter 1. Now my next question is going to say, calculate the reading on voltmeter V1. Alright, so tell me, what happens to potential difference in a series circuit?
Gets divided.
Gets divided. Alright, so potential in series, alright, V total is equal to V1 plus V2. In series, my total current, what happens to my total current in series?
Stays constant.
Stays the same. So I total is equal to I1 is equal to I2. So what is the current running through my 4 ohm resistor?
4,81.
4,81. Very good. So I'm going to write down my same formula again. R is equal to V over I. Now I know my current is 4,81. What is my resistance? Because I'm calculating V1.
4 ohms.
4 ohms. and alright, so then I get V is equal to 19,24. Alright, gives me 19,24 volts. What happens if you don't write the units?
You don't get the mark.
Yes, and I come hunt you down. And I find you. And you suffer. Okay. Question 4. Right, question 4 is where it gets a little bit more difficult. It says calculate the reading on voltmeter V2. Alright, so what happens to my potential difference in parallel?
Stays constant.
Stays constant, okay. So, in parallel, V total is equal to V1 is equal to V2. Alright, and in parallel, current splits up. So, I have my I total is equal to my I1 plus my I2. Alright, these are some formulas that you should remember, memorize. Alright. V total is equal to V1 is equal to V2, and I total is equal to I1 plus I2. So, in this component over here, the voltage through all of this component will be the same as the voltage through there, and the voltage through there. Okay. Sorry. So, if I look at this, I'm going to have, remember I calculate, my next step is to calculate the resistance across this parallel resistor. So, what is the resistance across that parallel resistor? 1,2, I already calculated it. So R parallel is equal to 1,2 ohms. Alright, so now, hope you guys remember, when we calculate the resistance of a parallel resistor and we get our total resistance, we can now treat it as a separate series resistor. Alright, so now I assume that through here, alright, I've got a 1,2 ohm resistor, and I can now treat that as a series resistor. Right, so when I calculate my total resistance, I can now treat that with my total resistance as a series resistor. So what is my current going to be through both of these together? Right, if I have to add the current of both of these together, it's going to be 4,81. Alright, so I is equal to 4,81 amps. Alright, so this is because my current through both of these added together will be the same as my total current, because I total is equal to I1 plus I2. So now let me calculate my, I wanted to calculate V2, so now I say R is equal to V over I. My resistance is 1,2, is equal to my voltage over my current of 4,81, which gives me a voltage of 5,77. Right. 5,77 volts. So that is my voltage on voltmeter V2. Okay. Which means the voltage through voltmeter V2 and through, so the 3 ohm resistor and the 2 ohm resistor will both be 5,77 because the voltage through parallel resistors remains the same. Alright, so my next question. Question 5. Alright, calculate the readings on ammeters A2 and A3. Alright, normally that would be split into 2 different questions, but I don't feel like writing out the same question twice. So we're going to do, calculate the reading on A2 and A3. So let's start with A2. My formula stays the same. R is equal to V over I. R is equal to V over I. Now, what is my resistance for A2? My resistance for A2. Here's A2. What resistance is A2 going to be measuring? 3 ohms. Alright. My resistance is 3 ohms. Alright, what is my voltage? 5,77. 5,77 over I, which gives me an answer of 1,92. I is equal to 1,92 amps. Alright. Now I do A3. What resistance value am I using for the reading on ammeter A3?
2 ohms.
Very good, 2 ohms. And my voltage is
5,77.
5,77 of my current. So now I say, gives me an answer of 2,89. Alright, I is equal to 2,89 amps. Alright, so now, there's a couple ways they can ask you your application question here. I'm only going to do one way, and the easier way for my grade 10s. Next week we'll go through a difficult electric circuits question. Alright, for now we're just going through the easy one. So I'm going to write number 6, an easy application question they can give you. Alright, if the 2 ohm, what would happen to the total current if the 2 ohm resistor was removed? Alright, I'm rather going to say with the total current increase, decrease, or remain the same, if the 2 ohm resistor was removed. Give a reason for your answer. Alright, so does anyone know what would happen to the total current? Would it increase, decrease, or remain the same? Yeah.
Increase.
Alright, total current will increase. Okay, how do we know that our total current is going to increase? What's our reason?
Because the current won't be divided anymore.
Yeah. Alright, my current won't be divided anymore. So, my first point is total current would increase. Sorry, I'm wrong. Ignore that. Total current would decrease. Yeah. Total current would decrease. Why would it decrease? So my total resistance would increase. So, resistance total would now be 4 plus 3 equals 7 ohms. Alright, so my total resistance has increased because I've removed the parallel component of my circuit. So now instead of having my parallel circuit, I've removed that and I'm left with my 4 ohm and my 3 ohm. Do you guys see that? So that's why my resistance has increased. So it will be decrease. Alright, the reason for my answer. The total resistance of the circuit will increase. Alright, if the total resistance of the circuit increases, R is equal to V over I. So now resistance has increased. What will happen to current? Current will decrease. Alright, total resistance of the circuit will increase. Therefore, alright, the total current will decrease. And my reason is because Alright? Resistance is inversely proportional to current. Right, and that is my 3-mark answer. So this is a 3-mark question. Decrease, total resistance of the circuit will increase, therefore the total current will decrease because resistance is inversely proportional to current. So I want to make another note here. I want to show you how I want you to answer this question. So do you see how I start with the word decrease? Alright, that's how I want you to start your answer because it makes it very easy for examiners to mark. You start with the answer decrease. Also, if you have no idea what the answer is, pick one of the 3 and guess, because you have a 1 in 3 chance of getting it right. Okay. Alright.